We were looking at other tests, as has been mentioned already. In a lot of these porous pavements, we really have a lack of standardized tests and things to do acceptance on. One of the things that the city was looking at is the new Hamburg test, which is what the WashDOT's currently using for their anti-stripping test for regular pavements. So we did send over a sample of our porous asphalt to run it through this. And basically it just puts a couple of pucks of your pavement mix in a temperature-controlled water bath, runs a steel wheel over it 10,000 times. Really simple in concept. And basically what it does, if you get 12.5 millimeters of deflection, that's when it's considered to be failed. Ideally on HMA pavements, you're trying to get to 10,000 repetitions or more before that happens. We got to 6,700 on the porous asphalt, so not quite there yet. The lab tech didn't think that was necessarily an anti-stripping or a stripping phenomenon, but thought that was more of a shear stress issue, which that there may be ways we could work on aggregate on that, but we haven't gone forward on it. Gives you some really neat results, gives you a 3D profile of the test area, which is kind of cool to look at. Don't know if it helps you out any, but gives you a real class. That's the actual just line graph showing how the test went. And the reason the technician thought that was not a stripping issue, because usually when you get a stripping issue, there'll actually be a deflection on that line. This one was just a straight line down. So that's why he thought it was shear stress instead of a stripping issue. We'll probably try to run that a couple more times on some samples, but unfortunately that test cost about $2,200, so I'm not going to run a whole lot of those tests. But it is interesting information to do. If you're using that larger diameter permeable ballast for your reservoir course, you probably want to do a choker course. And I didn't go into this, but some of the common thing, you can use smaller aggregate, as was mentioned earlier, for reservoir courses. If you're doing the smaller aggregate, you may or may not need to have a choker course for a stable working platform. But I think I haven't used it on any of my designs yet, but I will be on the WSU site. But Tacoma has successfully used the asphalt treated base. Again, as we mentioned, that'll give you a very stable platform to work on pavers with paving machines, and also give you a little bit different resilient modulus for the pavement design section as well. So it has a couple benefits on that without adding a whole lot of cost. And just for fun, right before here, I was looking up a couple of studies, and it appears that on at least asphalt-treated base, more asphalt in that case is not necessarily better. It doesn't actually increase your resilient modulus on that. So you don't need to put a lot of asphalt in. You just need to have enough to help it stick together a little bit on the asphalt-treated base. I haven't looked in detail at WashDOT standard specification. They're kind of open on their aggregate specifications for permeable treated base. So if you are doing a permeable treated base, you want to take a look at it, make sure you got at least, probably in this case, at least a 20% or higher void content to make sure it's going to pass the water at least as fast as your asphalt's going to do that. But other than that, any aggregate they have should work fine. Mentioning, again, we're a flexible pavement, so there's three things to consider when we're doing porous asphalt as far as the section thickness total. The design section, again, flexible pavements around the Puget Sound Basin, where most of us are working, you'd have basically a frost depth of about 1 foot. You're typically not going to have to worry about that, and here's why, because generally if you're in a soil that's fine grained, that's going to be a frost heave concern, generally that's going to be a poor soil, that your pavement section is going to be thicker than 1 foot anyway, so that kind of goes out the window. But just mention it so it's there as a thought in the back of your head about frost heave. That might be more of an issue with pervious concrete, because you can have sections in pervious concrete that will be less than 1 foot, but you typically won't with a porous asphalt section. So the other criteria is the hydrology, having enough reservoir space and storage space in there to allow your design storm to pass through and infiltrate. And structural design, which is almost always typically going to rule on porous asphalt, is what you're going to look at. And again, when you're looking at porous or asphalt, you want to be looking at the assumed poor saturated soils that you're trying to place this on and spread that load out over it. One of the ways you can do that is a quick and easy tool that WashDOT has out there. You can look at, they've got a flexible pavement design guide that has several different levels of use. The one we're showing here is for extreme low volume roads, but you would want to take this table and use the poor category. Again, you're going to assume that your soils are poor status and condition, and then get your HMA surface and your crushed stone or your reservoir course thickness directly off the chart. As you can see, if you have higher equivalent single axle load levels, which you can calculate out from your traffic information, you can determine if you're going to fall in one of those other categories. There's also they have a pavement design software, which I've unfortunately not been able to get to work because it doesn't appear to work on Windows 7 and Windows 8, and I don't know if they're going to be upgrading that or not. Our consultant has also got a in-house design software that he's using that I'm trying to see if he'll let me share with people like you so that we can spread that around as well. That would be helpful in doing these pavement designs for flexible pavements. And then again, there's another chart with a little bit higher uses, and here you can start seeing how you'll start getting thicker pavement sections if you're going with higher volume roads, and that goes up pretty dramatically. HMA and the base on the side is, they're going up to half a foot of hot mix asphalt at the bottom, all the way up to over a foot of asphalt. And quite frankly, you're probably gonna have to do it in rock with permeable pavement rather than asphalt, because if you can't get out there and do these subsequently, one of the other drawbacks of using porous asphalt is you really can't tack coat it, obviously. So if you're going to be days between asphalt lays, it could be somewhat problematic to do multiple lifts. I have done multiple lifts in the past on some projects, but they've only been 2-inch lifts, and they've been in subsequent days. So that could be an issue. Again, it's flexural pavement. You can increase your section strength by using more rock instead of asphalt. You'll have a little bit lower resilience modulus on that, so you'll have to use a little bit more rock than you would asphalt, but that would be a way to get your pavement thickness without having quite so much asphalt on your higher volume roads. I doubt many of us are going to be designing for the 100 million to 200 million easel loads on our roads. This is more in line with what you would see, light vehicle access. And this is, just so you know, the WashDOT does have some permeable asphalt design guidance that's available. And this is actually out of that section as well. So just a couple of construction things, and I think we've talked a little bit about this, but some of them apply for the higher levels too. If you're putting your aggregate levels down, you want to be looking for any sheen or sealed off areas on your aggregate as well. So that would be an indication that you've got too much fines in your aggregate. It's not going to infiltrate well. Make sure, as Chris mentioned, your subgrade hasn't been compacted by construction traffic. Watch for your asphalt in the beds, very drained down. Make sure your rollers are getting on the pavement in the correct temperature range as specified by your asphalt design mix. We don't want to be on there too early, don't want to be on there too late when it doesn't do any good. This is the one that hopefully getting out there now. We do want to do vibratory compaction, and actually I'll show you some information here that we just took from some of our city projects. But we do want to do vibratory compaction, and we want to get it down to 80 to 85% compaction. Basically, if you remember, we just said we want to have 16 to 22% voids in our mix. That's just an inverse of your percent compaction off your maximum density rice value. Hence, just back into it, 80 to 85% maximum density out there with your nuclear densometers. Once you get up to about 85, you need to tell them to back off and let it sit. But you probably want to, again, be up towards that higher end of the range, 83, 84, 85, rather than lower range, because we're trying to get to that durability issue. This is the WSU LID site in Puyallup, so it's a good place to compare and contrast what the two different types look like. Again, this is a dense graded HMA over here, and this is the porous here. You can see the visual difference in comparison there. That's so the one on the left is what you want to be seeing out there in the field for your porous asphalt. Similarly here, you have a section of the Foothills Trail I did early on in my career with porous asphalt. That particular choker course there probably is not going to do well. It's all sealed off. Should look more like the one on the bottom. So, quick question. So we got two choker courses here. Which one of those will probably work and which one won't? Bottom one is correct. Bottom one looks dirtier, but it's not all the same size. The top one is that choker course I showed you that did all the rutting. That's the one that's all one size. It also doesn't have a lot of fractured face on it, but it just is like a bunch of pea gravel. Won't hold up to anything and will rut extensively. So that's your visual test there on that one. As I mentioned, you want to be out there and get on the compaction. Don't want to get out there too early. That could cause you to get too much compaction. Could eliminate the voids that you're trying to remain in there, or it could be breaking down your aggregate level. If you're out there when it's too late, it's not going to do any compaction on there and reducing the getting higher compaction level. It's got to be within that range. Again, you'll have that range specified in your mix design. The only thing I was showing here is that if you have a foamed or warm mix asphalt, it typically has a little wider range of compaction for temperature, so you have a little bit more flexibility on that. There's some evidence to indicate that warm mix asphalt actually goes down a little bit easier and more consistently than regular HMA as well. But that's anecdotal from other people. I haven't seen it. So one of the things we were looking at, we were trying to look at what is our compaction and should be for test. So we wanted to take a look at that, and we took some of the City of Tacoma's data and some of the City of Puyallup's data from some of the projects we had done with porous asphalt, and started looking at that as far as what it was compared to dry density versus the percent voids. We looked at it for wet density for voids, and then it's like, well, yeah, we know what the air voids is calculated directly into the percent compaction, and we know what we want for voids, again, anywhere from 16 to 22%, so then therefore we know what our compaction percentage should be. And that's kind of just showing, this is all data from Puyallup projects. You can see we had quite a few that were outside the window there, but again, we didn't have machines out on there because we didn't know what we were supposed to be testing towards and what we should be shooting towards for the pavement, so we probably would have been hitting those ones that were in the lower, or excuse me, the lower percentages there a little harder. But you want to be out there with your nuclear decimeters and make sure you know what your rice value is, so you know what your percentages will be when you're out there. And that'll help you get a much more durable pavement. Again, porous asphalt, unfortunately, with the mixed designs we have now, they won't look a lot different than regular asphalt. Again, you can see this is the same two cells that we saw the gravel on. The one on the right is dense graded, and the one on the left is not. So there's not a lot of difference there. There's still some debate on, and I think it was already mentioned, acceptance testing for porous pavements. We're thinking around 200 inches per hour should be adequate for porous asphalt. Again, it's way more than we need, but it seems to be a reasonable test. I'm conducting some tests now on those same spots I took those density tests from. I should have those in the next week or so, and we'll see if that's in the right range. Most of the 8th Avenue project that we did in Puyallup has stayed at about 375 inches per hour, so it's been well above that. I think 200 is probably a very easy and achievable rate for acceptance, but still far more than adequate for what we need. Again, you want to look for any sealed off areas. Just real quick, a couple of post-construction things. Again, if you got private development that's out there and is doing porous pavements, you probably want to make sure there's something that goes with the land or with the property. When you get to the third homeowner, you hope they don't do what you're seeing here, which is they seal coated this previously pervious asphalt driveway. And it was about the third owner. It had gone through a bankruptcy, had gone through a bank and another owner, and finally got to this person, and I'm sure somebody got up and said, your driveway's leaking bad, you need to seal that. And they did. So you need to take measures to do that. Some of the things could be simple as putting up a sign, letting everybody know, hey, this is porous pavement, this is a stormwater facility. Make sure they can see that. Again, covenants running with land is what we're typically doing with a lot of our LID implementation in the city of Puyallup. That also helps get you there as well. Maintenance I'm not going to talk about because you guys are going to talk about that later. Education of maintenance personnel is obviously going to be key. We don't want our crews going out there and chip sealing or overlaying our porous asphalt. Utility installations, roadway repairs always gets a lot of questions. I'll leave that to you guys if you want to ask questions on that. Just a note on some of these things, porous asphalt has always been, everybody thinks it's going to clog. It's the first thing you got to do is worry about clogging. Yes, you do have to take precautions, make sure we don't have run-on, don't have a lot of sediments coming onto it, but there's been a lot of roads and installations have been in there, and including the original installation in Walden Pond in Massachusetts since 1977, still functioning today with little or no maintenance. So, I mean, that as long as we're out there maintaining the stuff, and Curtis will do that demonstration in a little while, we'll see that, it'll do fine. As far as rutting, again, the pavement gets all its section strength through the thickness of the pavement. It's an integral section. They all work together. The asphalt itself isn't going to be as much of an issue. I think where we've had some rutting issues before is we haven't hit it hard enough with compaction during construction because we've been really leery about losing those voids. Now that we know where to go on that, hopefully that won't be the case anymore. And we can get it down and get a firm and unyielding surface on that. Groundwater, Curtis will talk on that a lot later. That's a whole other issue, and I think it's pretty intuitive. We'll get there, and we'll do some more experimenting with the WSU project to get it there. But I always like to point out that the EcoStorm Plus is a GULD stormwater device. is used for water quality treatment in the state, and we have a couple of these installed, and installing a couple more. Pervious concrete itself is a good installation mechanism. Prohibitively expensive. Again, generally speaking, we're finding that you have a slight increase in cost on the porous asphalt. The section is obviously a little bit thicker than what you would normally do, so you're going to have a little bit of extra cost in excavation and rock. But again, when you start comparing that with what you would have to put in a dense situation, especially considering with your current stormwater manual, and if you're in a detention situation, we're talking large ponds and large areas to get to the forested condition, it can be much more cost effective to do LID. And there's some examples of there. There's also some examples of 8th Avenue cost. I love this aerial shot, so I like to throw it out there. That's the 8th Avenue project in Puyallup, and it's our information brochure for that. It's a pretty dramatic change from what the street was before. But again, the costs were not that significant compared to what we would have done on a typical road. Some of those other things you want to keep in mind are porous pavements. And again, this is that road in Texas I talked about, and everybody's been behind these in a rainstorm and been cursing because you can't see because of all the spray. But if you had a porous asphalt road, that's what it looks like. That's the same road, just a little bit further down in the same rainstorm. Reduction in spray is pretty much amazing. There's other benefits in there as far as hydroplaning. You don't have that water surface on there to be sliding on. You get a reduction in glare. You can actually see the striping and other markings on the pavement much better. The rest of that you all know already. On warm mix asphalt, again, I mentioned this could be actually more effective with porous pavements. The main thing here is instead of mixing your asphalt at 315 degrees where you have all the volatile asphalts and that are starting to boil off, which is why you see this big blue cloud around the top picture here, you're mixing it at a lower temperature, you're using a water emulsion to spread the asphalt out a little bit, but it's less energy consumption because you're not heating it up as fast. You're not getting as many emissions from it because you're not getting all those gases that are coming off because they're at that high, near the boiling temperature of that. So there's a lot of benefit, and just the poor guy that's out there paving gets to work on a much cooler surface too. So warm mix asphalt is a really intriguing option to continue to explore on porous asphalt, and hopefully we'll get there. With that, I think I made it. My information's on here. Feel free to contact me. I like to help people do porous pavement. Again, we've done everything in the city. We've done gravel pave, we've done pervious concrete, we've done pavers, we've done porous asphalt. We're continuing to do many major projects. We've got about 3 miles of arterials we're planning on in the next year or two and doing impervious concrete and porous asphalt. I'd love to get this out here and help other people and assist them in moving their projects forward.